This is the brief on the geometric and formal identities governing antisymmetric tensors. So, we're going to dive into some fundamental mathematical identities that come right out of general relativity. And what's really cool is how they connect the, formal math of tensor divergence with this really powerful, easy-to-grasp geometric intuition. Let's break it down into three key insights. First up, the geometry. What exactly is an antisymmetric tensor? Well, you can think of it as a field that's all about pure rotation or circulation. For these fields, its divergence, that's the outward flow, is basically just its gradient, but rotated 90 degrees. This means the flow is always perfectly perpendicular to the direction of greatest change, which is the very definition of circulation. Okay, second point. To actually calculate this stuff in curved space, you'd normally have to wrestle with these complex curvature terms, right? The Christoffel symbols. But there's a trick. A really slick identity lets us rewrite the contracted Christoffel symbols using just a simple partial derivative involving the metric determinant, g. So you get to sidestep all that heavy calculation. And finally, that little trick leads to a huge shortcut for the whole divergence calculation. The divergence of the tensor just simplifies. It becomes an expression that only needs the partial derivative of the tensor multiplied by the square root of g. So, g basically becomes this built-in correction factor, wrapping up all the complexity of curved space into one neat little package. Understanding these formal tensor identities confirms that even the most complex geometric calculations often boil down to fundamental movements like circulation and rotation.